Hi, we're going to predict the products of an electrolysis in aqueous solution. So in this question, we're being asked to predict the products of electrolysis if the solution contains zinc chloride. So the first thing is to make a list of what's present. We have Zn2 positive ions, we have Cl1 negative ions, and we have water, which is used twice because it could be oxidized or reduced. So oxidation 1 and 2, there are two possible oxidation reactions, and reduction 1 and 2. There are two possible reduction reactions. Since oxidation is loss and chloride has negative and can lose electrons easily, I choose the negative ion as a possible oxidation, and I choose water as a possible oxidation. For possible reduction, reduction is gain, so the positive ion is naturally going to gain electrons easily, so Zn2 positive is a possible reduction, and water can possibly be reduced as well as oxidized. So now I just need to find the appropriate reactions on the standard of reduction potentials. So for my oxidation of chloride, remember this table is a table of reduction potentials. So I need to reverse this. I need to find chloride ion on the right side to reverse the reaction. So here's chloride ion on the right side. If I write the reverse of this reaction, I will have the oxidation of chloride ion to produce chlorine by reversing this and reversing the sign of E0. So I need 2Cl negative produces Cl2, and reversing the sign on the reduction potential, which is 1.36, I write E0 is equal to negative 1.36. Now, to find the oxidation of water, I want to find water on the right-hand side, the same way I look for chloride on the right-hand side. We can see water on the right side in a lot of reactions. I want only water, but I don't want it forming from anything that I don't have in this solution. I don't have peroxide, so that's no good. It will always be the same reaction, 1, 2, 3. So if you simply remember counting up in order, 1, 2, 3, this is always the oxidation reaction for water that we want. We're going to have water, and it's going to break into oxygen and hydrogen ions that can easily escape. So I'm going to write this reaction in reverse. H2O produces a half of an oxygen two hydrogen ions, and 2 electrons. I think we're missing some electrons from the oxidation of chlorine. There were 2 electrons here as well. So E0 here, again, it's the reverse of 1.23, so negative 1.23 volts. Now with zinc, this is a reduction, so it's pretty straightforward. I don't have to reverse it or anything because the table is a table of reduction potentials. So I simply write this reaction as written, Zn2 plus 2 electrons makes Zn, and this potential negative 0.76 is good. So Zn2 plus 2 electrons makes Zn solid. E0 is negative 0.76 volts. The Reduction of water is a reaction that has only water on the left-hand side and nothing else. So here it is, negative 0.83. And this reduction of water is always going to be the same reaction every time. It will always be a reduction of water. So 2 water and 2 electrons. So 2 water plus 2 electrons. And I've just realized that my numbers will stand out if I do this. My coefficient to balance the reaction will stand out if I underline them. Just to be careful. 2 water plus 2 electrons is going to make 2 hydroxide plus H2 gas. E naught is equal to negative 0.83 volts. Now, we have a list. 2 possible oxidations, 2 possible reductions. The oxidation and reduction which occur are the ones that are easiest. How do I know which one is easiest? Well, if I have a positive potential, that's easy because it's spontaneous. If I have a negative potential, it's non-spontaneous, and the voltage tells me how much voltage I need to cause the reaction. So for the 2 reactions at the 2 oxidation reactions, we have 1.23 negative or 1.36 negative. This one's further right on the number line. It's a smaller amount in terms of magnitude that has to be provided. This is the reaction that will happen first. So although chloride ion is present, it's not oxidized. It's actually water that gets oxidized. Here, this is a smaller negative voltage. This is easier to provide than this. So zinc ion does get reduced. So if I write the overall reaction, I have Zn2 plus water, electrons cancel, produces a half of an O2 gas plus 2H plus Zn solid. When I add the potentials together, E naught is negative 1.99 volts, which indicates an electrolytic cell, a negative potential. Voltage has to be provided, and if I provide slightly more than 2 volts to this cell, it will cause it to undergo the non-spontaneous reaction. I will have an electrolytic cell when I provide negative 1.99 volts.